everyone, this is Shekhani of Sri Venkateshwara College of Engineering. Today I'll be covering one of the research paper which may be related to the subject of cloud computing. The title of the paper is Applications of Large Language Models in Cloud Computing, an empirical study using real world data. Moving forward, so the title of the paper is Application of Large Models in Cloud Computing, which carries a subtitle of an empirical study using real world data. The author of the paper is Hanze Li, Sherry-X Wang, Fu Sang, Kai Niu, and Ranzi Song. It was published in International Journal of Innovative Research in Computer Science and Technology, that is IJIRCST. So it was published in the year of July 2024, and we have some of the volume which it was published. Moving Introduction. So introduction we'll be having cloud computing transformations, large scale language models, that is LLMs, and why LLMs are used in cloud computing. So computing enables scalable, cost effective, and flexible services. Large scale data generation by cloud services necessitates advanced data management techniques. Also, LLMs like GPT-3 have shown potential in multiple domains, especially in optimizing processes and decision making in cloud. LLMs can process massive dataset quickly and improve resource management, ensuring effective handlings. So, because LLMs can handle a massive dataset quickly, and also it can have a resource management, ensuring effective learning. That's why we use LLM in cloud computing. So, this was the introduction which will be carried out about the paper, which we will be further processing in more detail. Moving forward, the objectives of research. The first objective of the research is to investigate LLM's impact on cloud computing performance. Second is automate cloud management techniques using LLMs, and few questions which will be answered in the forward research paper. So in objective 1, we have focused, like the authors are focused on CPU utilization, memory usage, uh, network latency, and storage optimization. And in automate cloud management technique, we have resource scheduling, predictive maintenance, and decision making improvement. And few of the questions are: how do LLMs improve cloud resource management? What performance gains can be attributed to LLMs? How do LLMs enhance cloud security measures, and what cost savings can business achieve through LLMs? Moving forward, large language models and their evolutions. So, initial models rely on statistical models that had limited capabilities and complex tasks. So, because there was not much uh, advanced of early languages, we had few of the languages to bring in and to shift to neutral networks. That is Yoshua Bengio introduces introduction of neural language model in 2003 enabled deep data analysis. And the transformer revolution. So transformers like Vaswani et al. 2017 allowed handling a large dataset effectively, and LLMs for cloud computing. LLMs process diverse data types, making them versatile for cloud computing, which involves multi-place resources management techniques. So move ahead, integration of AI and cloud computing. So how the integration and enhancement of AI. So cloud providers leading the way. So Amazon Web Services, that is AWS, Google Cloud Performance, that is GCP, and Microsoft Azure offer infrastructure suited for AI operation, including LLM deployment. And benefits of AI, as we have integration of AI and cloud computing, there are some of the benefits, that is scalability, real-time analytics, cost effective. So cloud provides the necessary resources to train LLMs and enabling them to handle large-scale data. And AI can process data in real time, offering immediate insights and adjustment. And by automating tasks like resource allocation and proper maintenance, AI reduces manual intervention. intervention, and association. So next, as we have seen few of the advantages, and these are few of the challenges that can be brought when we are using integration of cloud computing, that is complexity and security. So integrating LLMs into cloud environments requires sophisticated orchestration of resources, and ensuring LLMs do not introduce vulnerabilities into cloud infrastructure is crucial. It's crucial that LLMs do not introduce any kind of vulnerability. Moving forward, methodologies that are used, that is data collection. So first is data collected from cloud performers in AWS, GCP, Azure, IBM, and Oracle, and a source of a Kaggle dataset contained 5 lakh records of cloud performance matrices, and the time period was covered between January 2020 to December 2022. An experimental setup conducted experiment using three AWS EC2 instances type, that is T2, M4, and the next, and simulating different computing environments. LLM optimized instances were compared to non-LLM control groups. So the metrics evaluated are CPU utilization, memory usage, network, and performance collected at 5 minutes interval over 30 days. So using this matrix, the performance of each data was collected in every 5 minutes over the next 30 days. So results. Results were as follows. So CPU utilization, that is LLM optimized CPU utilization. So in that AW has 35%, GCP has 27%, Azure with 30%, IBM 20%, and Oracle of 40. And it also lead to lower and steadier CPU usage compared to erratic spikes in it. So memory usage, so average memory consumption, the T2 instances at 20 GB, M4 at 50 GB, C5 at 70 GB, and memory usage was predictable and consistent under LLM model. Then we have network latency and storage performance. So storage read and write speed improved in AWS was 150 MB per second, and we have a 90 MB write and 140 MB read. Moving forward, some of the discussions and limitations about it. So key insight is that resource efficiency, improved latency, and enhanced storage. So in resource efficiency, LLM optimized resources allocated, reducing CPU usage and preventing memory wastage. And LLM optimizes cloud setups, showing smoother and more consistent performance, and faster read and write operations were seen, enabling more efficient data handling. And some of the limitations are the study conducted over 30 days and longer period could reveal more insight. There was a shorter duration and limited instance type, that is T2, M4, and C5 instances represented a narrow range of cloud configuration and security consideration. The focus was primarily with minimal emphasis on potential security risk introducings of LLMs. And conclusion. So the paper made the following with more of LLM and it advantages, disadvantages, and what the overall of the paper is that LLM demonstrate substantial improvement in cloud services management, enhancing performance, reducing cost, and optimizing resource allocation. Predictive capabilities of LLMs minimizing over provisioning and bottlenecks and increasing system reliability. So this was a proper conclusion which can be made with the paper. So with the future research can have long-term studies, security implications, ethical consideration, expanding use cases, and energy efficiency. So we have more of the this thing related to this, that is extent of analysis period, and also LLMs can strengthen and expose to more vulnerabilities, addressing privacy and ethical issues, investigating LLM integration in IoT. These are the more future researches which can be done to enhance the research which is done now. Thank you and hope you understood the paper. So this was all about the LLM. that is a model, that is a language model that can be used. Thank you.